let's move on to object-oriented programming. So let's look at a simple program first. So this is a very simple program. What we are doing is we are getting the name of a student, we are getting the house of the student, and we are just printing name from house using f-string. And get name is just a function which returns after the inputting from the user. Similarly, get house is a function which returns the result after the user inputs the house. And where this comes from is like I was in school long time ago, and we had houses in our school, and I belong to blue house. There are 4 houses, 4 colors: blue, red, green, and yellow. So this is what this program is about. Let's run it first. This is obviously not object-oriented programming. This is a simple program. Let's enter the name. My house is blue, and it works. We can see that we have these 2 functions, get name and get house. And we could simplify it because name and house both belong to what? A student, right? So we could kind of simplify this program in some sense, or abstract this program with, say, I wanted maybe something like this. Get student, sorry, name, house. And we can define get student here, right? And we are here returning a tuple, right? And we can make it explicit as well. And because get student should return a student, maybe we should use it like this. We have the variable name student. Now if we use the student tuple, the index 0 is name and index 1 is house. And this should still work. Right? And it works. But here the challenge is like, okay, now you need to remember that 0 index is name, 1 index is house. And just imagine if it's a very large program, it becomes a pain and more prone to errors. So one thing we could do, we can introduce named indexing using dictionary. Let's do that. Let's create an empty dictionary student. We could have student with key name and user should enter the value. Similarly, this house, right? And we just return student. And now we are returning a dictionary. And when we call get student function, it returns a dictionary. And while using a dictionary, we use named index. Right? Now we are ready to run it. Let's clear the screen, run it again. Same thing. And it still works, right? And this is all fine, right? But again, the complication here is that there's no checking of house, right? For example, house could take values only out of 4 things, the 4 colors I told you, right? Red, blue, green, and yellow. So there's no checking of values here. And obviously, we could check it just before printing it here. But what if we could check it just while creating the student variable? And that's where classes comes in. Classes allows us to create custom data types. These are custom containers, which is kind of a blueprint to store data in terms of attributes and behavior. And usually it would represent something in the real world, maybe in the programming world, maybe in the real world. In this example, student is in the real world, right? So let's see how we can do that. So let's create a first an empty blueprint. How we do it? We use class function. The name of class is student. It starts with a capital S. That's the convention. And for now, I'll just use the path keyword just for placeholder. So we have not really added any details here. It's just a class student. We don't know what is inside, but that's fine. And what are the changes in get student? So similar to, we create a dictionary here using this function, right? But actually it is instantiating and creating objects. So instead of using dict and creating an object of dictionary type, we will create an object of student type similarly. So we have done that. Now instead of this indexing, which is special to dictionaries, the custom data type has an attribute name, which we access like this, and it has an attribute house, which we access like this. And let's see the type of student. And then we should also see the student. Okay, no, not now. Let's see the type. So everything looks good to me. Let's run it. Okay, so just like we create these attributes, right? We got the inputs on the user, we stored it in student.name. Name is the attribute inside the class. And we have to do the same here. Now it should work. Let's see. See, now two things. First thing is we printed a type of student, and see, it is its own type. We just created student class, and this object is of type student. And then we print student from house. So everything works as expected. So now this a question that what is the difference? I mean, we are using a dictionary, it worked. Here we are using like a custom thing, but it's no different in a dictionary. That's true for now. But what if there's no checking of inputs here, right? Here the house can take only four values: red, blue, yellow, and green. And there's no checking here. We just create an object without checking. We initialize the values, we initialize the object in some sense. It kind of doesn't look nice. There's no kind of validation of inputs. So let's see what we could have wished. Maybe we could have student here, and when we create the student object, maybe we want to pass on the name and house, and while creating only it will validate the inputs, right? Of course, till now we are not validating, and we can see we wanted something like this, but this will not work really, right? Because we just changed it and we have done nothing in here when we created our data type, a class student, right? Let's just run it and see. See, so it is saying type error. Student takes no arguments, and we have given two arguments. Okay, that's fine. So basically class is a special method. Let's do that. We have called double underscore init double underscore, and every method in a class or every instance function in a class has at least one argument which is called self, and then whatever number of arguments we need. For example, here we have two arguments, name and house. So what is self, right? So self is kind of an instance variable, and we can use this to refer the attributes of the class. So let's just first initialize it. We do self dot name is equals to name, self dot house is equals to house, and let's just see whether this error goes away. We've just added. So basically what happens is whenever an object is created, highlighted here, this kind of creates a new object. The first thing which happens is this init function is called. This is called a constructor. So while constructing the object, this is the first thing which is called, and it kind of initializes the attribute variables. Let's run it and see. It works, but still nothing has changed, right? Because the whole point of bringing this apply number 15 was we wanted to validate the inputs. So let's do that. So if house not in blue, green, yellow, red. So basically, if the input is not one of these four, we raise a value error. And we just say invalid house. So at least one validation is happening now. And this is great, right? So we just have this simple creation of object of class student, and we're feeding in the input while creation. It will validate before it creates, and that is what we wanted. So let's run it. Let's give the correct input first, and it works. Let's try with incorrect input, maybe black, and we get a value error. So now we are validating the input while creation, and the object will not be created if the input is invalid. Similarly, if you wanted, we could just check whether the name is empty or not, and we raise an exception, value error, missing name, and we are also checking if name is empty or not. Let's see if name is empty. We have blue and it raises missing name. And this is fine. Let's review what we have learned. First thing is whenever we create an object, this is called creating an object. So whenever we create an object, the first thing which happens is this init method is called and the instance is initialized. Self is the minimum input which every method needs. Self is something, we need something to store the name and house. We need something to store. Self is that thing. This is fine. Let's just, so yeah, so this double underscore, we need double underscore. So whenever there's a function which starts and ends with double underscore, it's a magic method which is expected from the language itself, and every other data type has that. Let's say I wanted to just print student and see what it prints, right? So nothing has changed. It's still the same. We take the inputs from the user, we create a student. While creation, it validates the value of the inputs, and then it creates the student. variable of type student. It returns that variable, and we are just printing student and the expected output. Let's run it. So we printed student, right? It doesn't look nice. Basically, it just says that there's some object at this address, memory address. We need something more readable, right? So there's a method which does that. It's called underscore underscore stir underscore underscore. So double underscore is sometimes called dunder. We call it dunder methods. So it takes the input self and it just returns a human readable thing. So let's say I have an f string and I print self dot name from self dot house, and because we are printing it nicely, we don't need it. Let's see. Let's run it again. See, it works. So now what we have done is we have created this underscore underscore stir underscore underscore function, and this is the function which is called whenever we print it, right? So this kind of describes our variable with values, and we can see what it gives us. So nothing has changed, right? So this is all great. There's one more problem. It can happen that after we have created the object, someone comes in and modifies the values and it now becomes inconsistent. There will be no error, it just shows us something which is not allowed. Let's see. See, def from black, which is not allowed, right? Black is not in the list. So this is a problem. So for that, we have getter and setter methods. Let's go back to the class. So ideally what we wanted was, so let's see this example, right? Student dot house equals. So whenever someone uses student dot house equals, we want a function to be called. Let's call it a getter method. And inside this, we just return self dot name. This is fine. But let's have a setter method. We have def name self. It takes two values, and one is the right hand side, one is the left hand side. So whenever we set this line, right? So whenever we are setting the instance variable, like student.house is equals to something, right? So that something is this after equal to, and this is what the setter receives. So let me just finish it and we'll see. Ideally, a getter would be just self dot name is equals to name. This is a setter method, right? Now the problem here is we cannot have a function and an attribute with the same name. So for that, we use this convention. The attribute starts with an underscore, right? So now what is happening is that whenever we ask for the name by using dot name, it kind of asks for this underscore name. Similarly, whenever we use student dot name is equals to, it calls the setter method and it sets the value of underscore name. The only difference is If you want to create it in Python, there's a decorator. It's called property. So now this becomes a getter method. And similarly, in Python, I wished that it was something else, but this is how it works. Name dot setter, and this makes it a setter method. One more thing, we wanted to validate it, right? Whenever we use this equals to, we want the validation to happen again. Let's do that. We can bring it from here. Okay, this name. So we use this one. See. So whenever we use, let's say student dot name something, let's say it's an empty string, we want it to raise an error. So whenever we do this student dot name equals, this function is called. And just notice that in getter and setter we're using this underscore, name underscore name. Just be careful of that. Let's run it and talk about it later. It raises an error because I tried to change it with an empty string which is not allowed. If it was a legal value, it will not create an issue. So now we have added getter and setter for the variable name. Similarly, we can add a getter and setter for house as well. So let's look at it from top to bottom. We create a student class. We create the constructor, dunder in dunder. We create our getter function for name. We create our setter function for name. We create our getter function for house. We create our setter function for house. The only thing is the logic for validating. We need it for the house. Now it's fine. So if you notice in getter and setter, we are always using this underscore house, and underscore name, right? But in the constructor, we are just using house and name because this also calls the getter and setter methods, which will validate the values. So we don't need this anymore. So these two also will call the setter method defined below, and it will always validate. Let's try it. We have our constructor, we have our getter, we have our setter. Again, we have a getter for the house, we have a setter for the house, we have our string representation of the object. We call our get student, we print the value student. Everything looks good to me. Let's run it. Here, run it. It works. Let's try for some invalid value, and it raises invalid house value error. It's good. It's able to validate, right? And now we do that again. Student dot house equals black. It should raise an error because this is invalid. Let's do that. See, it raises an error. All good. So we did so much to validate and keep the data consistent. Now, if I just do this, directly access, the values. We are able to again get an invalid value. Wow. See? So we did all this for nothing, right? We could still do it. So Python doesn't restrict the programmer, right? It's just a convention that anything which starts with underscore, don't touch it. Don't touch it outside the class. And you should just obey the convention. But Python doesn't stop you from accessing underscore house directly. It's just remove it, use good practices. So anything which starts with underscore, double underscore, don't touch it outside the class. That's the good practice. And all this kind of looks familiar now, right? We have created an object with student, right? And we have done this before. For example, let's see string, right? Let's just clear it all up. Let's create a string as hello, print the type of it, see what we get. See, it's a cluster. Similarly, we had a list and see the type of L and its class list. So this is not the first time we are using classes. We have been using classes all along. And these classes have methods. For example, L dot append 10. We would just append something and modifies the object L. See, similarly, we had S dot upper. Let's see. See, it converts to uppercase. Similarly, strip. Let's say I had hello world. I wanted strip on spaces. Anyways, the point was that we have been using classes all along. Similarly, there is dictionary class with dot keys and dot values. So let's move on to something else. Let's look at class methods. So let's say I have a class dice, and a dice has 6 sides. So ideally, we would want a constructor in the class which will be having self. That's it. And self dot sides is equals to 1, 2. You get the idea. Anyway, the point is that the dice has 6 sides. Okay, let's complete. And let's say I wanted to just throw the dice and we get a result, right? So let's say I have a function called choose, and we just print random dot choice self dot side. Now we are using a library called random, which randomly chooses from one of these. But to use that, we need to import it. Import random, and everything should work. So we create an object, guys, and then we print object dot choose. Okay, we don't even need to print because it's printing. So every time it gives us a different result. Now the problem is that whenever we create an object, it takes memory. But for our purposes, whenever we create an object, we don't need a new object, right? Because this will never change. And this is also something like a generic function, right? Which chooses from sides. So whenever we create an object here, we create this variable. And let's not do that, right? So if we create sites outside, it becomes a class variable which is shared among all the objects. So whatever number of objects you create, there's only one sites in the memory, which is a good thing, which it saves memory, right? But there's something which is fixed, it will never change. You don't need to create this every time you create a new object. That's good. Another thing is class method. So this choose operates on self, which is again, it works on the object you just created. You don't need that because at least for this example, everything is class based. It's not about the instance of the class. And for that, there's a special variable which is called CLS for class object. And if you want to access sites, you need to use CLS to tell that this is a class method. We have this decorator. And now what is happening is this is a class attribute. It is shared among all the objects if we create an object. And this class method is something which is kind of generic and can be directly called with the class name. Let's see that in action. So how can we use it, right? We can just use the class name with a capital D dot choose. That's how we use class methods. Let's run it. See, every time it gives a random value. See, this is class variables and class methods. So we just saw class method, and by definition a class method's first argument is CLS. A class method has access to class variables like sites, CLS.sites, right? So there's also something called static method. Let's say there is a function upper and it just takes a string s and returns it in capital, right? And of course we have this function choose which has first argument as CLS, and we have this upper function which has nothing to kind of do with the class, right? So it's not taking CLS, it is not taking self as the argument. So this is like a called a static method. It has no access to the state of the class and has a decorator called static method. So the difference between class method and static method is the class method is able to modify the state of the class. The static method has no access to the state of the class or the object, nothing. And of course, the usual method, let's say, I don't know, let's say test or something, which has a self in it, it returns, let's say, none. But yeah, the whole point is that if you need a class variable which is shared among all objects, it's the state of the class. This is how you define it. If the function takes the first argument as self, it is an instance function or methods. If the first argument is CLS, it has access to the state of the class. And if it's a static method, it has no access to the state of the class or object, nothing. So this is it. So here we can see again that there's a class dice. Sides is equals to a list of 6 strings 1, 2, 3, 4, 5, and 6. Now we can see that there are 3 kinds of functions. So one thing is that this sides is actually this list, and for any number of objects. So there's only one memory allocation for sides. Every time we create a new object, it won't be a new site. That's first thing. Second thing is, if the function's first argument is self, it's a method, and every new object has access to the state of that object, and we can access that using self. The second type of method is called class method. Add class method is a decorator for that, and this class method has access to the state of the class, for example sides in this example, and we can modify the state of the class if we wanted to. The third type of method here is static method, which has no access to the state of the class or the object. It's just a generic function, and there is no input related to the class, neither self nor CLS. For example, in this example, we are defining a method, static method upper, which takes a string and returns the uppercase of that string. And we can use that here, for example, dice dot upper. And we can obviously use dice dot upper outside this class as well. So this is static method, has no access to the state of the class or the object. Let's run it. Let's run it again. So one thing we can see is that we can see the results in uppercase, and it is randomly choosing from the 6 values. This works. Let's look at our previous program again. We have our class student, we have our constructor, where we are initializing the instance variable name and house, and these initialization are happening through setter methods. We have our dunder method, which shows the object in a nice way when we print it. And then we have our setter method, which returns the name. Getter method, which returns the name. We have a setter method, which validates the input and then initializes the name variable. Again, we have a getter for the house, setter for the house, validates the input, sets it, and then we have our getStudent function, which creates a student object, right? There's one more problem again, right? A class student is something which encapsulates everything related to student, right? Which is setting the name, setting the house, any functions which operates on students, everything is inside the class, right? But this getStudent is something which is again outside, right? Doesn't make sense to me. So what we can do is that transfer this function inside the class, and because it's inside the student class, we just need to name it get. This looks good. This looks good. Looks good. So one thing is that this function is something which doesn't depend on the kind of the state. So one thing we can do is say that this is a class method, and then the input should be CLS only one. Okay, other things looks good to me. And instead of using getStudent, we'll use student dot get. This looks good. And this should work. Okay, it's happening. Okay, we need CLS, I think. Okay, let's try again. Get the screen, run it again. It is validating. Let's try for some incorrect things. Black. Okay, it works. So what have we done? Let's see. So this is our class student. We have our constructor, which we have our dunder dunder function. We have our getter. We have our setter for name. And one thing to care about is that self.name is equals to actually is calling the getter setter method. So even though it looks simple, it is actually validating the values. These things are fine. And now what's new? What we have done here is we have class method and we have transferred the getStudent method inside the class because we wanted to encapsulate everything related to the student inside the class, because that's what the class does, is encapsulates attributes and methods, or attributes and behavior of the entity. And in the main we use student.get to access the class method. And let's run once more. It works. One more thing, in this example we created a class method, and if we look at it, it kind of doesn't depend on the state of the class. So what we can do is we can also make it a static method, and it should still work. Let's see. Wave blue, Wave in blue works. Wave in black should throw an exception, value error. It works, right? Green, it works. So yeah, this is all about static method and class method.